Let's open the model file. Here, I hope everyone can have a good habit. Every time before we actually start rigging, we must first check the model. This step is very important. When we get a model at work, if we find problems, we must send it back to the modeler and have the modeler make timely corrections. This way, we can ensure the schedule isn't affected. And when we are rigging ourselves, this step is also very important, because we can find many potential problems at this stage. If we don't do this and pile up these problems until later, when we want to change them, it might be too late. It might cause our rig to be scrapped and redone. This will undoubtedly create a lot of trouble for ourselves. Checking the model involves checking many aspects. First, let's look at the model itself. The first thing we need to check is the model's size. The model's own size and its proportional relationship with other models are all determined during the modeling step. We know Maya's default length unit is centimeters. So here, the model size, we need to ensure it's as consistent with real-world size as possible. But of course, we might fine-tune the size of each model later based on the shots effect. But it must always be adjusted based on the model's established scale and size. Next, we need to check the orientation. What is orientation? We know the world coordinate system has the z-axis as forward and the y-axis as up. When we get a model, we need to take a look. Take this car as an example. The front of the car faces the positive z-axis. The roof of the car faces the positive y-axis. Now, if we get a model where its front faces the positive x-axis, then we know this model has a problem. Here, we'll need to correct it, or send it back to the modeler to correct it. Another point is the model's center position. Let's look at this car. It has front wheels and rear wheels. The general center position of its four wheels is at the world origin. Now, if the car we get is too far back or too far forward, we also need to correct it. Another point regarding position is the overall height of the model. We'll need it to be as close to the ground as possible. Taking our car as an example, the very bottom point of its tires should be in close contact with the ground. It shouldn't have any floating or sinking into the ground effect. Now, if it's a human character, then it's the shoes the character is wearing. Or if they are barefoot, their feet must be in contact with the ground and not sink into the ground or float. Then, next are some steps we learn in modeling that I believe we are all very familiar with. For every model itself, we must freeze transformations. Ensure its translation, rotation, and scale are all at default values. Then, we must delete history. Then, on model parts, their pivot points must all be at the world origin. Next, we need to check the naming. For naming, the first thing we need to look at is called namespace. What is a namespace? A namespace is actually just a prefix. Depending on the modeler's import settings, when importing the model, Maya might automatically add some namespaces to the model. And this is a step the modeler needs to clean up when finally renaming all the parts. Let's look at the top level group right now. Everyone will see that this name has a colon before our normal naming format. There's another word in front. Well, this is actually a namespace. How do we clean up namespaces? We can find the general editors in Windows, and inside there is a namespace editor. Then we'll see all the namespaces in the scene. For a model, when we pass the model to the downstream departments, this file itself should not contain any namespaces. So here we select this namespace and then click Delete. At this time, a window will pop up. We just choose Merge with Root. Then we will delete it. Our original node's name will return to how it should be. Next, let's look at the naming itself. All our models need to strictly follow the naming convention. We've talked about our course naming convention before. We use double underscores. The order here is type, side. Since it's a model, there will be LOD. Then description, and finally, a 4-digit index. And because like our tires, it has distinctions like left front, left back, right back. So our side actually has two parts, and they are connected by a single underscore. Let's expand on naming in a bit more detail. First is our naming for left and right. Here we need to be careful. When we define left, center, or right for a model's name, it is determined based on the model itself. For example, this door model. Let's take a look. For this car, it is actually the door on the car's left side. So the name we give it must be L. And correspondingly, the door over here is the right side door. So it must be R. A common mistake we sometimes fall into is when we are defining left and right, some of us might think it's defined by our own left and right hands. What does that mean? For example, this car is facing me right now. I select the wheel. I think this wheel is on my left hand side. So I name it left. This is actually incorrect. For the car itself, it is the right wheel. So it must be R here. Same idea, if we are working on a human character, then we should also know when we select, for example, the character's own left hand, the corresponding left-right type must be left, not right. We must be extra careful about this. Another point we need to pay attention to is when we are naming these parts left or right, we must be extremely meticulous. Don't misname them. For example, this tire should be on the left, but due to carelessness, I named it right. In that case, it will cause a few problems. One is when the rigger gets this model and looks at these model names, it will be very confusing. For a car like this, it's still okay, because we are relatively familiar with the car's parts. So if any name is carelessly wrong here, we can actually tell at a glance. But if we get a more complex mechanical model, or a mechanical structure we are not very familiar with, then we can quickly spot if this part was misnamed due to carelessness, or if it has a special effect. For example, although it's on the left, it's actually part of a right-sided component. Then we'll need to spend more time figuring it out. Obviously, that's very inefficient. And another reason, speaking of car rigging, we generally write some scripts at work to automate this process. When we run these scripts, it will read the name of each part. It performs the rigging based on its left, center, or right identifier. So if the name is wrong at this point, if I name the left wheel right, then the controller that was supposed to control the right wheel will now end up controlling some functions of the wheel that is on the left. Obviously, this effect is not what we want, so we must be careful here. Continuing with naming, with the naming here, we need to name each of our parts as clearly as possible. What does that mean? We see many car parts in my scene here. If I don't categorize them, and I just name them all mesh C low car parts 0001 all the way to 9999, that would be very unclear. We wouldn't know the actual function of each part. But of course, like I said, for a car, it might not be that troublesome, because we are quite familiar with this mechanical structure. But once we get a more complex mechanical model or a mechanical structure we are not very familiar with, this will definitely cause us a lot of trouble. But if we name it more clearly, like for example, the naming I have here, I'll just pick an object, we can see this object. Through my sight and description, I know it represents the car's front hood. Then I select this tire. I also know it's a tire for the front wheel. So in this case, I can more easily grasp the actual function of each part and thus improve our own work efficiency. Another point we need to pay attention to is grouping. Grouping here is actually like naming, is to make our entire mechanical structure clearer. Like the tires here, there is a group above it for all the parts of the left wheel. Because as we can see, my wheel has many parts here. And when we are rigging, we've practiced this before. We should all know that we don't perform any operations on the individual model itself. Instead, we ultimately put them into a specific group. So if it already has some groups here, this will give us a good understanding of the mechanical structure's intended motion, even without studying it in depth. Next, we need to check the model's topology. But because we are rigging a car here, this is a hard surface model, and we won't be doing any deformation on this car. So we can skip this step here. But if we are rigging an organic character, the requirements for deformation are higher. In that case, we must be sure to check the topology. Also, for mechanical models, there's one more point to note. We need to check the connection status between parts. For example, the windshield wipers here need to rotate. We need to see if its pivot point and its connection are reasonable. And the hood. It also has an effect of rotating around this position as its axis. So we also need to see if it's tightly interlocked here. Also, like the chassis here, it has all kinds of parts. These are all things we need to check. This step is very important for mechanical rigging. Because if the modeler didn't follow actual mechanical principles during modeling, it's very likely to cause the rig to be unable to achieve the desired effect. In that case, what we need to do is discuss it with the upstream departments. There are two situations here. One is that the concept artist or modeler indeed didn't notice this. Then they will modify the connection to comply with the actual mechanical operating principle. Then we proceed with rigging normally. The other situation is that they did it this way for a better visual result, and in doing so, ignore the inherent mechanical operating principle. This reason is actually very common. As we've all seen in many blockbuster movies, some robot or mecha structures, for the sake of looking cool, their parts between one and another, don't actually connect in perfect adherence to real-world mechanical principles. In this situation, it's up to the rigger to compensate as much as possible in the rig to make it look as reasonable as possible visually, without obvious intersections. But regardless of the situation, as riggers, we need to know this in advance, because depending on the situation, it will ultimately affect how we handle these parts. The decisions we make will be different. So here, we must not forget to check this part. So after we have checked all these aspects, it means this model has met our rigging requirements. Then we can officially start the rigging work.